Hello everyone. I'm going to explain about classification of ECG waveforms for the diagnosis of diseases using Wavelet transform and artificial neural network. So basic introductions about the paper is since this paper belongs to digital signal processing and it also is a part of pattern recognition. Uh, we have utilized the recently developed tools such as Wavelet transforms and neural network, that is artificial neural networks, for the detection purpose of cardiac arrhythmias. As we know that this electrocardiogram is nothing but it used to record the electrical activities, and it comes under bioelectrical signals originated from the heart. To recognize the arrhythmias or abnormalities, we can say the working of heart is very important to know how the work functions, and on the basis of the functioning of the heart, we used to plot a graph that is nothing but recorded by a electrocardiogram, that is a machine, and by manually now the manually the diagnosis process is to take place by the doctors and experts. The objective of our work is to design a neural network or artificial neural network classifier, supported by Wavelet transform, so that the automatic process can be done for the diagnosis of such kind of diseases. The main architectures of our project, or we can say our papers or researches, that we have taken the raw ECG input, to the and we have fed it to the wavelet transform. So wavelet transform is the first part which used to pre-process the signals, and then this pre-process signals we used to send it to the neural classifier. It may varies, many types of neural classifiers can be used, and which used to classify and diagnosis, which can be sent as a diagnosis purpose to the to other phases, like it can be classified as a normal and abnormal ACC. Now the basic abstract what we are doing actually, basically we are classifying the ECG waveforms on the basis of Wavelet transform, and the neural network used to classify these signals in the two types, and we have utilized the MIT Artmia's database, pick up 45 files out of 48 files, and we on the basis of their signals we have selected 25 files as a normal class and 20 files as an abnormal class, so that what we'll do, we'll have a pattern like 25 files based on normal normal patterns, and 20 files as abnormal pattern. So what we are proposing, that we'll finally will study these signals, will have a preprocess, will process these signals on the basis of value transform, and finally will classify on the basis of their patterns using back propagation neural networks. Look at here the basic information about the electrocardiograph. It has the regular patterns, and it contains the five types of waves, that is P waves. The initial wave is P wave, which is just due to the cardiac variations, and then after the QRS complex, that is Q wave, RS, and S wave combinedly. Then we have T wave, and sometimes we have also a kind U wave, but it is not present every time. And between these waves, we have the segment called PR segment, TR segment, Q2 segments, and all this. So from this graph, we can see that how the normal ECG waves, normal ECG patterns looks like. Now normal conduction pathways, how this wave generate is, you can see, like P wave is caused by the arterial depolarization. QRS complex, this QRS complex is caused by the ventricular depolarization, and the last, this T wave is just because of the ventricular repolarization. um, so cardiac conduction systems will come to the main topic, that is called Wavelet transform. So first, why we are applying Wavelet transform? Wavelet transform is nothing but a tool which used to nothing but simplify or process the signals which contains some uh, noises and other kind of things. It is mainly nothing but it has two parts, that is approximation and details. When basic raw signals is passes through this Wavelet transform, it it converted, I mean it suppresses the low pass signal, that is high frequency components and low frequency components, and it gives the appropriate basic based upon what we have applied. Now neural network, what neural network do? Neural network is nothing but a classifier which used to classify based upon the given information, provided information. We have generating the weights, inputs we are giving what we have as a raw preprocessed ECG, I mean after passing through the wavelet, and then there's a summing junction finding out the output on the basis of the information. Now proposed method, what we have proposed? We have taken the raw ECG. Look at here. Now we are denoising on by using Wavelet transform. Denoising also have the baseline wonder removal. Baseline wonder removal nothing but the variation from its original path. Feature extraction. Now based upon after denoising and baseline wonder removal, will extract the feature, and this feature is fed into the ECG classification, that the classifier, and it classify in abnormal and normal ECG. Now database, already we have discussed about, we have taken the MITBI database. Pre-processing stage, in pre-processing stage we are denoising the ECG signals using Wavelet transform, and you can look at here the final output. We found original ECG signals that has the very much noise containing, and now it is the denoised signals which is suppressed from all the noises what it has, but still it has the variation, that is baseline wonder. So this baseline wonder, that is from variation from this original zero path, we have removed, and that is called baseline wonder removal, and it is nothing but a smooth signal starting from zero. Next, look at it, the result. What we have utilized that raw noise AC signals, and we have found that denoise and suppress AC signals in this form. Next, feature extraction. We have extracted features by the two methods: morphological features of AC signals and wavelet coefficient based features. So the first one, the mean of the absolute values of the detailed and approximation coefficient at each level we have taken. A standard deviation and detailed approximation coefficient we have taken. Variance values of detailed approximation coefficients we have taken. And the second part, like morphological features like PR segment, PT segments, and all these segments. The record number we have utilized is normal records and abnormal records. Normal records, these are the records number, that is the file number 100, 101, 103, 105, like that. And this is the classification performance result using back propagation neural network classifiers. We found here that using neural network classifier, the normal class we have given one, I mean normal class out of 25 classified as a 24, but one wrong classification we found. But in the abnormal class we found all 20 files as a normal class. So overall accuracy is 97.8%, which is quite good. So conclusions is, you can conclude that the abnormality detection using back torsional network is very much efficient in case of abnormality. Normal classes we found 97.8% of this one. Features, we have taken a very good features like 64 features, including morphological as well as statistical features, and it can be improved further while taking other types of classifiers and have been improved. So thank you, and you can ask me your any queries through my email, which I have mentioned here on first slide, on harimonda@gmail.com, and I hope so you'll understand the concept of classification of ECG. Thank you.